Hey, Algebra 2, we're going to learn about 4 different parent graphs. The first one that we're going to start with is absolute value. So a parent graph is the simplest graph of a family of functions. And then later on, we're going to start transforming them. That means we're going to eventually move them left, right, up, down. We're going to stretch them and flip them. But first we have to start with the basic parent. So I think the easiest way to do that is to just start off with a table of values. The table of values, for all of these, you have to choose both negative and positive numbers, otherwise you won't see the full shape of it. So in most cases, I'm going to use -2 to +2. All right, so I'm just plugging these values in for x, and I'm going to solve for y. So I have the absolute value of -2. Absolute value is always positive, so that would be my y value. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is +2. 1, 0. All right, so now I have these 5 ordered pairs, and I'm just going to plot their points. -2, 2 is right there. -1, 1 is right there. I have 0, 0, which is at the origin. 1, 1, and 2, 2. I'm going to finish connecting the dots and sketch in the rest of my graph. All right, so absolute value has a couple of characteristics. It is always a V shape. Always, always, always. There is symmetry around your vertex. So the vertex in this case is 0, 0. There's my vertex. It's either the highest or the lowest point. And what I find super helpful on these is knowing that there is symmetry. And so if you just kind of made an up and down line that went through the vertex, then you can see if you have a 0.1 unit to the left of that symmetry line, you have a 0.1 unit to the right. If you have a 0.2 to the left, you have its mirror image 2 to the right. So knowing that there is symmetry is very helpful. In the last section, we started domain and range, and now we're going to require it on every single problem. This particular domain goes -infinity to +infinity. So you have to remember that domain are your x values, and any value works here. You could plug any number in for x that you wanted, and you could solve for y. Your range are your y values. So remember, we started doing this on piecewise. It's your distance up and down. So we always go from smallest to largest. So I notice that 0 is your smallest y value, and then you have this side going up to +infinity, and that side also going up to +infinity. So the range on this parent function is 0 to infinity. The quadratic would be the next parent function that I do. The quadratic is called that because your biggest exponent is a 2. I'm also going to make a table of values. Their x values are going to go -2 to 2. So I'm going to plug these values in. So -2 squared equals +4. -1 squared is +1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So you need to know that a negative times negative is a positive. If you don't, and if you put it in your calculator, you have to use parentheses so that you get the correct answer. Plot these points. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And that is the parent quadratic. This graph has a name. This graph is called a parabola. It is always U-shaped. This one also has symmetry around the vertex. So this one has a vertex at 0, 0. So we have, you kind of drew in that up and down line that goes through the vertex. You can see that you have symmetry. If you have a point 1 to the left, you have its mirror image 1 to the right. Here I have a point 2 to the left of this symmetry line. I have a point 2 to the right. The domain are your x values, and once again, any value works. So when any number works, we say that your domain is -infinity to +infinity. Your range measures your distance up and down, so your range is your y values. And I see that 0 is my smallest. And so this one also goes from 0 to infinity. All right, let's go to the back side. We are going to do a cubic function. Cubic is going to be one of our basic parents that we use. We are also going to use x values of -2 to 2. So I have -2 to the third power, or -2 cubed. A negative times a negative times a negative still equals a negative. This value is -8. -1 to the third is -1 times -1 times -1, which equals -1. 0 cubed is 0, 1 cubed is 1, and 2 cubed equals 8. Let's plot these. Oh, finish writing them down. 0, 1, 8. Plot these points. So we always start at the origin. I'm going to go left 2 and down 8, plot a point. Left 1, down 1. 0, 0 is at the origin. 1, 1 is right 1, up 1. And 2, 8 is right 2, up 8. So when I connect the dots, I'm going to try to make it as smooth as possible. And then you need to put tails on each end. So this is going down to -infinity. This one is pointing up. It's going up to +infinity. This one generally has an S shape to it. I know it's not exactly an S, but it's kind of that like wiggly little shape. Your domain. Domain is X, and once again, any value works. So this domain is also -infinity to +infinity. Your range is your Y values. So this one's different. I get both negative and positive values. So since I get both negative numbers and positive numbers out, this range is also -infinity to +infinity. And then you can tell that arrow is going down to negative, That arrow is going up to positive. And then finally, we're going to graph our square root function. So maybe you're ready to just say, all right, so my x's are -2 to 2, right, Kathy? Ugh, God, I wish. So if you get on automatic mode, if you plug -2 into your calculator, I think it says no solution or something. On second square root of -2, it would say domain error. It says domain error because when you try to take the square root of a negative, it is actually an imaginary number. Same thing with square root of -1. It is also an imaginary number. So here, you can only use numbers greater than or equal to 0. I'm going to choose what I call perfect square numbers because they are going to be easier to plot. What is a perfect square, you ask? So a perfect square is when you can take the square root of a number and you get a regular number out of it, such as 0. Square root of 0 is 0. So your answer, recall, is your y. 1 comes next, and that happens to be a perfect square. The perfect square of 1 is also 1. So my x is 1, my y is 1. The square root of 2, no, not a perfect square. Square root of 3, no, that would get me a decimal. Square root of 4, oh, that one's a good one. Square root of 4 equals 2. So if x is 4, y is 2. And then what's the next perfect square you come to? That would be 9. The square root of 9 is 3. So these are the points that I'm going to plot. 0, 0, 1, 1, 4, 2, and 9, 3. So if you connect the dots, it's not a line, but it does have a curve to it. And its shape is actually a half of a parabola on its side. A lot of people think that it kind of looks like a check mark, so you see the radical sign here, and that kind of looks like a check mark, and this graph and that symbol kind of look like each other. So that's how a lot of people try to remember it. All right, so what is your domain? This one is different than all of the others. So 0 was my smallest value I was allowed to use, and then they keep getting bigger and bigger and bigger. You can look at the graph and see that 0 is the smallest, and they keep growing. So 0 is the smallest, and then they get bigger from there. So this domain is from 0 to infinity. Your range measures your distance up and down. So this is my smallest y value right here. I don't have any negatives. So if you look at the graph, 0 is your smallest. And then from there, that is going both up to positive infinity and right to positive infinity. This is also 0 to infinity. This domain and range will be your most challenging, but that is a summary of parent functions.